In this video, we'll go over a quick example of how to do persistence through adding a registry key that will run a payload on user logon. Looking here, I already have a session set up for the host .132, and it's running off this payload that I have staged in the C drive. So if we want to create a registry key that will execute that payload for persistence, let's take a look at regedit. First, in case you want to target a specific user, you could check under HKey users, and you'll see a list of SIDs, or security identifiers. Each user account is associated with a security identifier, and you could find the current user's SID by typing whoami/user. Here is the SID for Jason Bourne, and it looks like it's here as well under registry editor. You could go under software, Microsoft, Windows, current version, run, and you'll find a registry key OneDrive, which is linked to a file that will run when Jason Bourne logs in. But in my example, I'll set the registry key in a place that will target any user logging in. Under HKey local machine, software, Microsoft, Windows, current version, run. Now let's add a registry key that will execute test.exe whenever a user logs in. Let's go into the session and open up a shell. Now to create this persistence, we'll use the registry add command. We'll set the name to test. We'll set the file to test.exe for it to run, and we'll force this. I like to use /f to force this command because if there's a registry key with the same name in there, it'll ask a question if you are sure you want to overwrite the registry key. And because this has interactivity issues in the shell, it might break. So let's see if the registry key was created by refreshing this. It looks like the registry key was created. Now let's log off and log back on. So it looks like we lost our session, but hopefully when he logs in, our persistence will kick in and we'll get a new shell. Great, it looks like a new session popped up. And you can see that the user is jason.bourne. Now let's log into another user to see the effect take place on them as well. Looks like a new session came up. The session is for Jane Doe now. For this video, we'll be going over persistence through scheduled tasks. We'll just do this directly on a Windows machine so we can show the effect in real time. First, I'll do whoami/groups so I can make sure I am in the domain admins group. As you can see here, I am in the domain admins group. Let's take a closer look at scheduled tasks. As you can see, scheduled tasks enables an administrator to create, delete, query, change, run, and end scheduled tasks on a local or remote system. For this persistence effect, we'll do /create, so that way we can create a scheduled tasks in the background to enable our persistence. So I'll type in the command scheduled tasks /create / to get more information on the /create parameter. Looking at /create, we have multiple extra parameters we could throw in. Notice the parameter SC for schedule, MO for modifier, and then the /TN for task name, and /TR for task run. Scrolling further down, you can find more information on each of these parameters. As you can see here, the /TN and /TR, we can find more information and even an example. So let's combine these parameters to have scheduled tasks run and execute calc.exe on the computer every 10 minutes. Let's have the assumption that calc.exe is a payload we uploaded onto the system that will give us a new session every time it runs. So we'll run the command scheduled tasks /create /TN for the name of the scheduled task /TR for the command we'll run, which will run calc.exe directly, and then /SC to schedule it every minute, and the /MO modifier to run every 10 minutes specifically. Great! Now that the scheduled task is created, we could always check to confirm that the scheduled task was created with the /query parameter. Let's run /query to get more information on this command. As you can see, it enables an administrator to display the scheduled tasks. Notice the /TN for task name, and remember the task name we used from before, calc. So let's type the command scheduled tasks /query /TN calc. Looking under time, we can see the next time that it's scheduled to run is at 10:29 p.m. If we look at our clock, it seems to be quite a while until the time comes for our effect to run. So let's go to our clock and change the time ourselves. Now all we have to do is wait a few more seconds. And then at exactly 10:29, it looks like calc pops up. Let's do persistence, from creating a service that will run a payload on the host every time the host is booting up, from starting or restarting, getting a system level shell. Right now we have a session opened on the host .132. From this test.exe payload that we have in the C drive. So we'll create a service that will run that payload every time the system boots up. If you watch the service's lateral movement video, you'll see that we had to create an exe service because it was a more stable way for a payload to run through services. But for this demo, I'll show another way to run this payload, specifically this test.exe we have uploaded. To do that, let's first go into the shell. Now let's create the service. Let's call it test. And for bin path, we'll do something a little different. We'll type command.exe/k, which if you look over here, do cmd/?mark to get more information. We see that /k carries out the command specified by string but remains. So let's set the path to test.exe. And also for persistence, let's set start equals auto. So it'll start up every time the computer starts up. Now that the service is created, we can always check more information on the service with scqc or scquery. Let's restart the system to see the effect take place. We lost the session, but hopefully we'll get a new one when it reboots. Awesome. Looks like we got a new session. And it looks like it's system level. In this lecture, we'll be going over how to do persistence through a WMI event subscription. But first, we'll go over a lesson of WMI and how you would view current subscriptions on your computer. WMI stands for Windows Management Instrumentation. Microsoft implemented WMI for the use of accessing management information in a Windows Enterprise environment. Management through WMI can be done both locally or remotely through a written WMI script or an application to automate the administrative tasks. There is a wide array of management actions that are possible from WMI, ranging from the configuration of security settings to execution of processes. Now in comes permanent WMI event subscriptions. These are persistent objects that last until removed from the WMI repository, which are capable of monitoring and triggering off a wide variety of events. These WMI event subscriptions can be set up through a PowerShell or MOF file that you create. The event subscription is made up of three parts: the filter, which will narrow down the type of event you want to trigger on; the consumer, which is the action; and the binding, which combines both the filter and the consumer. Just take note that you have to be administrator to create WMI event subscriptions. The filter for WMI event subscriptions narrows down the specific event and delivers it to the consumer, so the consumer executes an action. The filter can trigger off specific events such as a processor being created or deleted, or even a change in the system's time. The consumer is the action that takes place after the triggered event. You have a range of consumer classes you can choose for the action, such as a command line event consumer for command line based actions, to the SMTP event consumers, which sends email based on an event. The binding just binds both a filter and consumer, so the filter sends notifications to the consumer you choose. Alright, next we'll go over how to look at the current filters, consumers, and bindings on the system. Then we'll create a permanent WMI event subscription that will trigger a payload off an event by writing a MOF file, then running it. Okay, let's take a look at the current WMI event subscriptions. First, we'll look at the namespaces that are available. We have the option of doing it in Wimic, or we have the option to do it in PowerShell. Here are all the namespaces available on your system. Let's take a look at the classes available in subscription. We'll type GWMI namespace and we'll look under root subscription. Great, let's take a look at some of these classes. Couple interesting ones to note is this one, event filter, all these consumer classes that are available, and also filter to consumer binding. If we wanted to take a look at the current event filters on the system, we could always type GWMI namespace, look under root subscription, or other namespaces if you're curious as well. Then class, and specifically event filter. It looks like there's only one event filter currently on the system. And it looks like it triggers off of any Microsoft SCM event log event. We can look at event consumers by typing GWMI namespace, again under root subscription, class, and we'll look at event consumer. So we have one again. Its name is SCM event log consumer. Now let's list the bindings. Let's just type get WMI object, namespace, look under root subscription again, and we'll target filter to consumer binding. So again, there's one listed, and you can see the binding it has between the filter and the consumer. Okay, let's go over the creation of a MOF file. We'll call it test.mof, and we'll open it up in Notepad. Okay, so a MOF file is a managed object file, and we'll use it as a way to create new event filters, consumers, and bindings. For this first example, we'll create a permanent event subscription that will execute test.exe in the root of the C drive. And hopefully when this executes, we'll get a new session. For this first example, what we'll filter on will be every time the process calc.exe is killed. So first, we'll set the namespace to root subscription. And you'll see I added a few more backslashes because I have to escape it for a MOF file. Next, we'll create the consumer. I'll name it test consumer. And what I'll do is I'll use this command line event consumer to execute test.exe. And now I'll create the filter. I'll call it test filter. I'll set a query. To filter off a specific consumer. Let's take a look at the classes available under root subscription. Let's use instance deletion event, so whenever a process is killed, the filter will send a notification to the consumer. Do this within 5 seconds. Set target instance is a Win32 process. And we'll set target instance name as calc.exe. So let's check what the process name is. Looks like the name of the process is Win32 calc.exe. Set the event namespace to subscription. And last, we'll create the binding. So we want to bind the filter with a consumer. And that should do it. Let's try this out. Save it. Check that's there. And we can run a MOF file by typing mofcomp and then the file name test.mof. Looks like I have an issue, so I'll fix it really quick. It was just a little typo. We'll resave and we'll try again. Looks like it was successful. Now let's close calc.exe to see if we get a session. Awesome. Let's go into the session. And there you go. Looks like we are system. Let's check to see what the filter looks like on the system. So we have test filter here, and we could see what query's on, which is whenever there's a deletion event of a Win32 process and the process name is win32calc.exe. Let's look at the consumer now. So we have our test consumer here, and it executes test.exe. Let's do one more WMI event subscription example, except instead of triggering on win32calc.exe being killed, we'll trigger off of a modification of the local time on the host. To do this, instead of instance deletion event, we'll do instance modification event. And instead of win32 process, we'll go off of local time. For the time, we could go off of the year to the month, to the day, to the hour, to the minute, and to the second. For this example, I'll show it by the hour, to the minute, to the second. Let's do it the next 3 minutes after where we currently are. We'll say an OR, so we can have multiple minutes to choose from. And we'll finish it with an AND target instance second equals 30. So it'll trigger on the 30-second mark of one of these minutes in the hour, which it's 1 a.m. right now. and for this, I'll set it to the namespace CIMV2 because the subscription version of Instance Modification Event has been a little buggy for me. We'll save it and let's run it. And you can see the reason it didn't work is because I had a typo. So let's set it to the next minute. Recompile it and try again. And it should execute in a few seconds. And there you go. Let's go into the session. And look, we are NT Authority system. In case you want to delete the WMI event subscription, here's a way to do that. First, let's query the filter and see what the name is. We could see the event filter we created, and the name of it is test filter. There is an option to delete WMI event subscriptions with PowerShell, but for this demo, we'll use Wimic instead. With this Wimic command, we are targeting the namespace root subscription, the path event filter, and deleting the filter where name is test filter. Let's run the command, and it says it's successful, but let's query the filters again to see if it's still there. Alright, looks like it's not there anymore. Next, let's delete the consumer. First, let's query all the consumers to see what the name of our consumer is. And it looks like it's test consumer. Now let's run our Wimic command to delete the consumer. For the Wimic command, we'll target the root subscription namespace and delete the consumer where the name equals test consumer. Now after running this command, let's check to see if the consumer is still there. Looks like the consumer is gone now. Now finally, let's delete the binding. First, we'll query the bindings to check to see if it is there. Next, we'll run this Wimic command to delete the binding in root subscription under filter to consumer binding where the filter is equal to test filter. Let's check to confirm that it is gone. And looks like it's gone. Now we have deleted the WMI event subscription that we put in place. Alright, let's go over golden tickets. In a Windows domain, a golden ticket is pretty much the keys to the kingdom. It is a self-generated ticket with domain admin rights on the network. The golden ticket can be seen as a form of persistence, because if for some reason you ever lose access to a domain admin account, you can always use a golden ticket to get access again on the domain. We'll go over a demo of how to use Mimikatz to get the information so you can create your own golden ticket. There are 4 components you'll need for creating a golden ticket. The user account you want to create the ticket for, the domain SID, and the KERB-TGT hash. So let's check our current sessions we have. And right now I have a domain admin session and a domain user session. But to get the KERB-TGT hash, I'll need to have a domain admin account. So let's go into that right now. So for the KERB-TGT hash, I'll use Mimikatz. Let's look for Mimikatz. And this looks like a good one right here. So let's save that path. And then we'll go back into the session and upload it. Alright, let's go into a shell. Go into Mimikatz. And to get the KERB-TGT hash, I'll use LSA dump. And looking at the LSA dump modules, you can see DC sync right here. So we'll use DC sync. And look for the KERB-TGT hash. So right away we could see some interesting information we should hold on to. For example, the domain name and the name of the domain controller. Here's the NTLM hash of the KERB-TGT. And here's the domain SID. We can ignore the last number. For the user, you could use any user account, but I would recommend using a domain admin account to replicate. So let's look at the domain admin accounts on the network. So here's a couple domain admins we could impersonate. Let's use Jason Bourne. Now that we have all the information we need to create a golden ticket, let's create it with Mimikatz. But currently I'm in the domain admin account, so already I do have access to the domain controller. So there's no use for me to create a golden ticket for this demo on this account, but that's why I have a domain user. So let's go into the domain user session. Let's upload Mimikatz. Drop into a shell. And let's just confirm we are a domain user with limited privileges. As you can see, he is a domain user but not a domain admin. And also let's confirm we cannot access the domain controller. Access is denied. So let's create the golden ticket. So we'll use this command in Mimikatz, which you can see a list of Kerberos modules to use in Mimikatz right here. So we'll set the domain to fun.com. the SID right here, the hash for the curve TGT, and the user account jason.born. Looks good. Looks like the golden ticket was successfully created. Let's confirm it was created by listing it out. Now let's test to see if we have access to the domain controller. And looks like we have access to the domain controller as a domain user.